Welcome back to 2024 question 4. So the image across shows a toy helicopter packaged for display. The body of the helicopter is based on an ellipse. Okay, so we've got an elliptical helicopter body. Part A. The image below shows a pictorial view of the helicopter. Match the correct letter with the appropriate orthographic view shown in the table. One view has been completed for you. So B here, looking in from the rear. See, there's the rear of it. So B is going to be completed. So that's done. Right, first one. Looks like when we're looking down on top of it. So looking down on top from A. Next one is looking in from the front. So looking in from the front here, we see D. And then finally, looking in from the side, okay, we can see the propeller and we can see the legs of it, I suppose, which is C. Right, so a nice, easy one to get us going there. Next up, we have part B. Shown below is designed for a helicopter landing pad. The outline of a similar pad has also been shown. Divide the line AB into 5 equal parts and complete the drawing of the landing pad. Show all construction clearly. So, first things first, AB divided into equal parts. So, I'm going to draw a line here from A at any angle. Okay, I'm going to step off 5 times because it's 5 equal parts. So compass, set it to any distance. 1, 2, 3, 4, 5. And I'm going to join that last point back to there. Okay, so that's the important line. Okay, now I have that line, I can use sliding set squares to draw, a parallel line from each one of those. So that's my important line. I'm going to slide back, create a parallel line here, there, parallel. Parallel. Okay, so now I've divided AB into 5 equal parts. And then to complete this, I need to draw my circle. So compass again. First arc is first distance. Okay, next one, we'll extend our radius, make it a little bit longer there to our next circle. Then on to our next one. So pretty easy after this, it's just about drawing it accurately. Good compass work needed. And our final circle. All right, so that is question B completed. Question C. The 3D image on the right shows the packaging for the toy helicopter. Shown below is the elevation and end view and incomplete development of the packaging. So elevation, end view, and here's the incomplete development. Okay, complete surface development of the packaging. So with elevation, I get 2 dimensions. I have my height and I have my width. Okay, with my end view, I have 2 dimensions. I have my height and I have my depth. Okay, so we have the width projected down there. It seems to be the same width. Okay, I'm just going to project down a little bit further. So something like that. Okay, and they have drawn what appears to be the base here, and then this side folded down. So let's just check that that is that side folded down. So that should be the height. So that's the height folded down. Yeah. Okay. I'm also going to need that height for other parts of it. We'll come back to that in a second. So my width, I've projected down. My base now of it is going to be the width by the depth. So I need the depth of the base. Swing an arc down. Swing an arc down. Okay, and that is the position now of the base. Well, hidden detail that, not hidden detail, fold lines going across. So, and I'll finish off the given fold lines. All right. Now, we want to do our opposite side. So this side folded down. So it's going to be the same as this. We're just going to need our height. So the height. And I'll swing that down here and that down here. So that's going to be second side. Okay, what's left now is the two sides. So this folded down and this folded down. Okay, so here's essentially the shape we're trying to find, okay, because they have a height and they have a depth. Okay, so we have the height and the depth. So I want to draw them in this position. So we just show that they're going to be there, there. Okay, the height will be the same. So that height, swing it off, but you can see there they're linked up to the same height. They're the same on this side, just to show the height again. Okay, so let's draw that, and we've got our two sides completed. Okay, so that's my surface development for part C. Part D, using a tick, indicate the correct answer to complete the following statement. The sum of the focal radii PF plus PF1 plus PF2 is equal to this, this, or this. Okay, so what they're saying there is P to F plus P to F2. Okay, if I add the two of those up, what are they equal to? And they're actually equal to the major axis. Okay, so that distance plus that distance is equal to the major axis. Okay, and typically what you'd see as a construction is F joined through P and extended, and we get that distance and rotate it on, and you actually are able to find the full length there if they haven't given you the major, but they have in this case. What they're asking us then in part 2 is construct a tangent to the ellipse at point P. So this is a very common construction. You would definitely complete it as part of your studies. Sorry. So P1, we draw a line through, sorry, F1 through P, F2 through P. Okay. Now if I bisect this angle, I'll get a normal. But if I bisect this angle, I'll get a tangent. Okay, so what I'm going to do is bisect that angle. Okay, so that's my first bit. Set my compass, set it to any distance, swing an arc, where those arcs cross each other. I have a tangent. Okay, so that is my tangent construction. We can draw that tangent any length we want. Okay, so tangent. Right, so that brings us to the end of that part of question 4. Next up is our ellipse part for question E.